Hello dear students. So today we are going to take up another physical property, electronegativity. This is important property in case of covalent compounds. Now what is electronegativity? So a quantitative measure of ability of an atom in a chemical compound to attract shared electron to itself. This is called electronegativity, right? Now let us take an example. For example, first it has to be taken in covalent. Let us take an example of covalent molecule, that is HCl. It is formed by, covalent molecules are those, yes, which are formed by mutual sharing, that is one electron of hydrogen and one electron of chlorine. Although chlorine has 7 electrons, out of which 6 electrons are shown and the 7th electron is this. Now it requires 1 electron, so it will share that electron from hydrogen because hydrogen has 1 electron. So during that process what happens, its octet gets completed. In the same manner the duplet of hydrogen also get completed. So I am taking an example of HCl, right? It's a covalent compound or covalent molecule. Now this HCl has these 2 electrons, right? Now they should remain in the center, right, at equal distance because they are shared. But what happens, due to this property of electronegativity, this chlorine tends to attract this shared pair more towards itself. As a result, what happens, H, and now there will be distance. This electron cloud has shifted more towards Cl, thereby it will acquire delta negative charge and it will acquire delta positive charge. Now this tendency of this chlorine to attract the shared pair towards itself in a covalent compound is called, what we call it as, electronegativity. Unlike ionization enthalpy and electron gain enthalpy, it is not a measurable quantity. Okay, a number of numerical scales of electronegativity elements have been developed. The one which is most widely used scale is Pauling scale, right? Linus Pauling in 1922 assigned arbitrarily the value of 4. He has selected this number 4 to fluorine, and this fluorine is considered to be most electronegative element as it has the greatest ability to attract electrons, right? So some of the values are given in this scale. As we can see, electronegativity values are given on Pauling scale. So Pauling scale is generally used in order to predict electronegativity, right? And this variation is given across the period. So if we take this second period into consideration, second and the third period elements are given, so electronegativities are also given related with fluorine, right? So fluorine towards right side, this fluorine has highest value, that is 4, and now the rest elements in the periodic table, they have lesser value than fluorine. So fluorine is most electronegative element. Which species will be most? Fluorine has highest negative, that is 4.0. Now analyze this. Lithium 1, beryllium 1.5, then 2, boron, carbon 2.5, nitrogen 3, oxygen 3.5, and finally fluorine. Then downwards if we move, so chlorine 3, in the same manner for third period elements, sodium, magnesium, aluminum, so on. So fluorine has highest or strongest tendency to attract shared pair, right? The electronegativity of any given element is not constant. It will depend on the element with which it is bound, right? Both the elements, they will have different electronegativities. As a result, the nature of the bond, that will be determined as per their difference. Although it's not a measurable quantity, but it provides a mean of predicting the nature of force that holds a pair of atoms together, right? That which type of, or how much will be the ionic percent, or what will be the ionic character, or whether the compounds will be more covalent or they will have some partial covalent character, like all those. So that can be predicted on the nature of the force, right, by which the two atoms they are held together. Now the variation of electronegativity. So in general, electronegativity, it increases across a period, that is from left to right. Now we can see the second period elements, lithium to fluorine, right? So the electronegativity value goes on increasing, as already explained that as per that Pauling scale it's given, right? So fluorine has maximum electronegativity. Now how can we explain that why fluorine has maximum electronegativity? So basically it can be related with size. So smaller the size, greater will be the electronegativity of the species. So as you know that fluorine has smallest size, so its electronegativity will be maximum, right? Now then variation down the group. So electronegativity generally decreases as we move down the group. Again on that Pauling scale, who has given the representation of values of various elements as per their electronegativity, we can relate. So let us select this group 17. So group 17 elements are given here: fluorine, chlorine, bromine, iodine, astatine, and their electronegativity values are given. So fluorine, as we have discussed, it has maximum value. Now downwards again electronegativity value goes on decreasing. Again the reason can be explained on the basis of size. Downwards the size goes on increasing, hence the electron attracting power of the element that goes on decreasing. Okay, same thing in case of alkali metals, if we are to relate with alkali metals. But since this is the main property of the non-metals, we can say non-metallic character increases as the electronegativity increases. Okay. Now periodic trends of elements in the periodic table, how electronegativity can affect or it can change, or what will be the nature of the compounds or elements. So all the properties that we have discussed, electron gain enthalpy, if you remember, electron gain enthalpy, it goes on increasing in negative as we move along the period or across the period. In the same manner, ionization enthalpy, that also goes on increasing along the period or across the period. And in the same manner, electronegativity also increases. Okay, but if we relate electronegativity with atomic radius, so along the period atomic radius decreases. That means we can relate it with size or electronegativity is inversely proportional to size, right? As per this we can conclude. Okay, means atomic radii along the period or size along the period goes on decreasing. So the value of electronegativity or electronegativity, this property, it goes on increasing, not value, but this property goes on increasing. Now we can relate it with metallic character. Now along the period or across the period, that is these two groups, they are S block, and S block, as you know, S block elements can be regarded as metals. They are metals. Downwards, what are metals? Metals which are electropositive, which means which have the greater tendency to release electron, thereby they will acquire that positive charge after losing electron. So electropositive, they are electropositive means they have greater tendency to release electrons. Now downwards, what happens to metallic rector? We will discuss these properties again in chemical properties. But metallic rector goes on a tendency to release electron. It goes on increasing down the group because of increased size. So we can again relate these properties with size, right? How? Size becomes bigger, electronegativity decreases. Metallic rector with size increases. Okay, so that means the elements which lies towards left side of the periodic table are more metallic than the elements which lie to the right side, that is towards halogens or chalcogens. Group 16 and group 17 elements, they are non-metallic. Okay, so since with decrease in size, non-metallic rector increases, and likewise electronegativity also increases. Okay, so these were the trends of electronegativity. Dear students, with this we have completed all the physical properties. All the physical properties are concluded now. Under this we have discussed about atomic radii. We have discussed about atomic radii, in which ionic radii was also included. Then we have discussed about ionization enthalpy and its variation factors affecting, and we have also discussed about electron gain enthalpy. Right? And finally electronegativity. Okay, so these were the physical properties. Now we will move towards chemical properties in next video.